All right, so next we are going to be covering compositions of functions. So f of x equals x squared plus x and g of x equals x plus 1. Find each of the following. So this is f composite g of x. So what they want us to do is they want us to take the f function and they want us to plug in the g function. Okay, so the way that we're going to do this is we're going to go ahead and start off with the f function. And everywhere where we see an x, we are going to leave it blank. So we have blank squared plus blank because it's x. Okay, and then in there they want us to plug in our g of x function. So my g of x function is x plus 1. So in these spaces, I'm going to go ahead and plug in x plus 1. All right, so here x plus 1 squared plus x plus 1. Now this one we are going to have to multiply it in a box. So I'm going to make a box here to the side. So box method, because x plus 1 squared means the same thing as x plus 1 times x plus 1. Okay, that's how we have to multiply it. So x times x is x squared, x times 1 is 1x, 1 times x is x, and 1 times 1 is 1. So for this section here, we get x squared plus x plus another x plus 1 plus this x plus 1. All right, so now f composite g of x, looks like fog, but this is supposed to be a little circle of x, this part right here, is equal to, and then we're going to go ahead and combine like terms. So first we have x squared, that has nothing to combine with. Then we have x, x, and x together, that gives us 3 x's. And then 1 plus 1 is 2. And that's it. That is f composite g of x. All right, so now we're going to go backwards. So what if we take our g function this time? So we take our g of, and then instead of g of x, they want us to plug in f of x. That's what that means. Okay, so that means that we start with the g function. So I'm going to take my g function. My g function is x plus 1. So I'm going to leave it as blank plus 1. And inside the blank, we plug in our f function, the x squared plus x. All right, so we have nothing outside these parentheses. We do not have a number here in the front to distribute. We don't have an exponent like we did on the previous problem that we need to take care of. There's nothing that we have to take care of, so we just go ahead and write it out. It gives us x squared plus x plus 1. And there's no like terms to combine, so that means g composite f, not goff, g composite f of x is equal to this. And that's it. All right, the next one. Okay, it says given f of x equals x squared plus 3x and g of x equals 5x, find each of the following. So here we have x squared plus 3x is our f function. So we're going to take our f function and we're going to plug it into our g function, we're going to plug it into our f function. So we start off with our f function. My f function is x squared plus 3x. So it's going to be blank squared plus 3 times blank. Okay? And then my g function is 5 times x. So in these blanks, I'm going to plug in 5 times x. This one's 5 times x. Okay, so this one is a little bit different when we square it because it's not 2 terms, okay? It is 5x. On this one, it was, x plus 1? So we had to multiply in a box method. But this one's just 5x, so you just square the 5 and the x. 5 squared gives you 25. X squared gives you x squared. And then plus 3 times 5 gives you 15x. These two, we check to see if we can combine, but we can't because they're not like terms. So that means that f composite g of x equals 2x squared plus 15x. So that one wasn't too bad. All right, the next one. So here we have g composite f of x. So what that means is they want you to take the g function, and inside your g function, you're going to plug in your f function. So we start off with the g function. So my g function is 5 times x. So instead of x, remember you leave it blank. And in that blank, you plug in your f function. So my f function is x squared plus 3x. Okay, so this time we have this 5 outside of the parentheses, so we need to distribute the 5 to each one. And we get 5x squared plus 15x. And then that means that g composite f of x is equal to this. All right. The next one, we have f composite g of 2. So here, we're going to take our f function, and then we're going to plug in our g function. And then instead of x, they want us to plug in 2. Okay, so we're going to start off with f. So my f function is x squared plus 3x. So x squared plus 3 times x. Okay, and in those blanks, I am going to plug in my g function. So my g function is 5 times x. But remember, we're not putting x. They want us to plug in something else for x. Okay, so that something else that they want us to plug in is a 2. So I'm going to put a 2 here and a 2 here. All right, we can plug all this in our calculator exactly the way that we see it. So let's see, 5 times 2 in parentheses is 10, and 10 squared is 100, plus 30 gives us 130. So that means that f composite g of 2 equals 130. All right, so if you didn't get that example, we still have another one. So on here, it's g composite f of -5. So this time we are going to start off with the g function. And inside the g function, we are going to plug in the f function. But instead of f of x, it is going to be f of -5. Okay, so let's go ahead and start off with the g function. My g function is 5 times x. But remember, we leave a blank. And then in that blank, we are going to plug in our, I don't think I left enough space, sorry, for my work. And then in there, we're going to plug in our f function. Our f function is x squared plus 3x. But remember, we don't put x, we leave a little blank so that we can go and plug it. And in those blanks, they want us to plug in a -5. So -5 and -5. And then we can go ahead and put all of this in our calculator the way that we see it. We can also do mental math, which is what I'm doing right now. So -5 squared is 25, plus -15 is 10, and then 5 times 10 is 50. So f composite g of, what was the other way around? -5 is equal to 10. Sorry, we did the g composite f. G composite f. All right, the next example. So given f of x equals x squared plus 2x plus 1 and g of x equals x minus 1, find each of the following. So we're looking for f composite g of x. So we're going to take our f function and we are going to plug in our g function in terms of x. So my f function is x squared plus 2 times x plus 1. And so instead of x, we are plugging in our g function, which is x minus 1. So here we have x minus 1 squared plus 2 times x minus 1 plus 1. So we're going to have to do the exact same thing that we did on the previous problem. I'm going to do it here to the side. Because we have x minus 1 squared, that means the same thing as x minus 1 times x minus 1. So x times x is x squared, -x, and positive 1. So that's what I'm going to plug in here. So that is x squared minus x minus 1. Oh no, it's a plus 1. It's a positive 1. And then this 2 we do have to distribute to each one. So it'll be plus 2x minus 2. And then at the very end, we have this plus 1. So last, all we got to do is combine our like terms. So f composite g of x is equal to, the x squared has nothing to combine with. Here we have negative x, and a positive 2x. So that leaves us with no x's at all. And then here is plus 1, and minus 2. I should have done that in a different color. Those also cancel each other out. And so we are just left with x squared. So this would be our answer. F composite G of x is equal to x squared. Okay, because all these canceled. All right, the next one, G composite F of X. So this time we're taking our G function and we are plugging in our F function, and they do want us to leave it in terms of X. So let's start off with the G function. My G function is X minus 1, so it's going to be blank minus 1. And then in that blank, we're going to plug in our F function. Oh, I didn't leave enough space. Whoops. So it's going to be x squared plus 2x plus 1. Okay? And so on here, like I said previously, we don't have a number here in the front to distribute. We also don't have an exponent here that we're going to have to go ahead and multiply. So that is going to stay like it is. So all we got to do is combine our like terms. So our like terms are positive 1 and negative 1. They cancel each other out. So that means G composite F of X is equal to x squared plus 2x. Okay. So now they want us to practice plugging in a few numbers into this. Okay, so we have F composite G of negative 1. So we are going to take our F function first. So my F function is x squared plus 2x minus 1. And so I'm going to do blank squared plus 2 times blank plus 1. Okay. And then from there, we are going to plug in our G function. So our G function is x minus 1 squared plus 2 times x minus 1. But they don't want us to put x's here. Instead of x, they want us to plug in a negative 1. So I'm going to put negative 1 and here negative 1. So we can plug all this in our calculator exactly the way we see it. We can also do some mental math, which is what I'm going to do. So negative 1 minus 1 is negative 2. Negative 2 squared is 4. Plus negative 1 minus 1 is negative 2. And 2 times negative 2 is negative 4. And then at the very end, we have a plus 1. So these end up canceling each other out. So that means that F composite G of negative 1 is equal to 1. All right, the next example. So we have G composite F of 3. So they want us to take the G function, which is x minus 1. So we're going to leave it as blank minus 1. And in that blank, they want us to plug in the F function, which is x squared plus 2 times x plus 1. Okay? And then they do not want us to put an x. They want us to put a 3 in there. So I'm going to plug in a 3 here and a 3 here. And so 3 squared gives us 9 plus 6 plus 1 gives us 16 minus 1. Okay, so that means a G composite F of 3 is equal to 15. All right, so I think that's kind of repetitive. I think you guys get the point. So I'm going to go ahead and skip through. And I want to get to the graph one. So here it says, use the graph to find each of the following. So what they want us to do here is take the F function and plug in the G function at -8. So these, because it's a graph, we do work them a little bit backwards. We first look at the inside, okay? G of -8. So what this is saying is that when x equals -8, what is my y value? Okay, on the G function. So this is my G function. I'm going to highlight it in purple so I don't confuse them. And then this is my F function. And so I am looking when x is equal to -8. So 1, 2, 3, 4, 5, 6, 7, 8. Here's -8. what is my y value? So this is the point we're looking at. Okay, my y value in that case is 1. So instead of that, I'm going to put a 1. So now we're going to look up f of 1. So at f of 1, what this is saying is that when x equals 1, what is my y value? So then I'm going to look up. Here's where x equals 1. Now we're looking at this point right here. My y value happens to be 4. So this is equal to 4. All right. So let's go ahead and try the next one. So let's see, G composite F of -6. I'm going to erase my work here. Sorry. So on here, we have G of, oh, G is purple, not pink. G of F of -6. Okay. So what this is saying, when x is equal to -6, what is our y value? So I'm going to look on here, -6. So 1, 2, 3, 4, 5, 6. This is the point that we're looking at. Remember, we're looking at our f function, not our g function first. And my y value is equal to 3. So now we're looking g of 3. Okay, so what does this say? This is saying when x is equal to 3, what is my y value? And the y value, we're looking on the purple graph, your g function. So when x equals 3, 1, 2, 3, we're looking at this point right here. And it is 1, 2, 3, 4, 5, 6. So it is equal to 6. All right, the next one, F composite G of 0. So let me erase this again. So this time we're starting with our f function of g of 0. So what we have to do, okay, they put a 0 instead of x. So we're looking first at the g function. When x is equal to 0, what is our y value? So here is 0. Our y value, remember we're looking on the purple function. Our y value would be 1, 2, 3, 4, 5, 6, 7. Our y value is 7. So that means we're looking for f of 7. So then, what does this mean? This means that when x is equal to 7, what is my y value? So we look up 1, 2, 3, 4, 5, 6, 7. And remember looking on our f function, which would be right here. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would equal to 10. All right, the last example. So here we have G composite F of -3. So we are taking our G function, and in our G function, we are plugging in our F function when x equals -3. So this is saying when x equals -3, what is my y value? That's what we start off with. So x is -3, 1, 2, 3. My y value here, remember we're looking at the pink function because that's f of x, is 0. So that means that we are looking for g of 0. Okay, so when x equals 0, what is my y value? So here we're going to look up 0 on our g function. So when x is 0, my y value is up here, and that is 1, 2, 3, 4, 5, 6, 7. So it is 7. And that's it. So let's go ahead and try a few more problems because I know these are a little confusing. Again, we have F and G, so I'm going to do my F in pink and my G in purple. Just so that I don't mix them up. It helps me out a little bit. I'm a very visual learner, so I have to see it. So now the first one is F composite G of -6. So I'm not going to write down all my work, but we're going to look up when x is -6, what is my g function at? So here's -6, 1, 2, 3, 4, 5, 6. My g function is at 0. So we are looking for f of 0. So then we're going to go ahead and look up when my x value is equal to 0, what is my y value? So my y value is 1, 2, 3, 4, 5. So that would give us 5. All right, so let's go ahead and try the next one. This one wants us to take our f function and then find our g function at 2. Okay, so first we are going to look when x is equal to, I don't have a lot of space to write this down, when x equals 2. So let's go ahead and look on our g function. When x equals 2, my g function is down here, which is 1, 2, 3, 4, 5, 6, 7, 8. So it is negative 8. So we're going to do f of negative 8. And then from there, we're going to go ahead and take negative 8. So we're looking when x equals negative 8, what is my f function? So here, wrong direction. 1, 2, 3, 4, 5, 6, 7, 8. And my f function is 1. Okay. Now we're starting with the g function. So they want us to find g of f of negative 10. Okay, so we are looking for when x equals negative 10. When x equals negative 10, what is my f function? So negative 10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My f function is actually 0. So that means we are looking for g of 0. So that means now we're looking for when g, on our g function, when x equals 0, what is my y value? So here is 0. My y value on my g function is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last example, so g composite f of 6. So we're going to start off with our g function. And we are plugging in 6 instead of x into our f function. So we're going to check when x is equal to 6, what is my f function? So I'm going to check 1, 2, 3, 4, 5, 6. My f function is up here, which is positive 2. So they want us to find g of 2. So then we go ahead and check out. When x is equal to 2, what is my g function? So at 2, here's 2. My g function is down here, which is 1, 2, 3, 4, 5, 6, 7, 8. So it is negative 8. And that's it. If you guys have any questions, go ahead and let me know. We'll see you guys later. Thank you. Bye.